Hello everybody. In this video, we will start our discussion on algorithm called Prefix Sum and how to implement it in parallel. Now in STL, there are few functions provide the facility of prefix sum, like partial sum, inclusive scan and exclusive scan. The underlying functionality is very similar for each of these functions, but there are few minor differences and we will look into those as well. So let's first start our discussion by looking at the functionality of prefix sum algorithm itself. Given a sequence of number, let's say x0 to xn, prefix sum calculate second sequences of numbers y0 to yn where yi is equal yi minus 1 plus xi. So in the output sequence, first value of y0 will be x0 itself. y1 will be y0 plus x1, which is the same as x0 plus x1. y2 is y1 plus x2, which is same as x0 plus x1 plus x2. I think now you get the pattern. Ith element in the output sequence will be the summation of all the values to that index, including the value correspond to index itself in the input array. So if we have following sequence as the input, what would be the outcome of the prefix sum operation? Please pause the video now and try to write down the output sequence for this input sequence. Okay, so the first value will be the first number in the given sequence. Second value will be the summation of first two numbers in the input sequence. So the value will be 3. And the third value will be the summation of first three numbers in the input sequence. So the resultant value will be 6 and so on. So the output sequence would look like this. Please check whether you got the correct answer as shown in this slide. Now let's try to implement sequential version of this algorithm. So let's have a function called sequential partial sum which take the start and end iterators alongside the iterator to store the outputs. Then we obviously have to iterate for start to end iterator. Then we can simply implement the equation we saw in the presentation. For that, here we need the length of the list to iterate, and first element of y is the same as the first element in the input array. So let's assign that value and then we can iterate in a for loop. Inside the for loop, we can simply write down the equation yi is equal xi plus yi minus 1. Pretty straightforward. Now let's check the validity of this implementation. So let's call this sequential implementation from the main function, and here I am going to use 10 element vector to test the functionality. So let's declare that vector here and assign values 0 to 9 to this input vector. And then let's pass this vector to our implementation, and finally we can print out the output vector using for loop. Okay, let's run this example. Okay, as you can see here, the values printed are as expected as we saw in the presentation. I have implemented this algorithm to make it more clear for you guys, but STL already have multiple implementations of prefix sum algorithm, and let's look at those algorithms now. So in STL, we have inclusive scan, exclusive scan and partial sum algorithms. Let me first clarify the difference between inclusive and exclusive scan. These algorithms have introduced with C++ 17 standards. In inclusive scan, to calculate the ith value in the output, we consider ith element in the input as well. But for exclusive scan, we will not consider ith value but all the values until the ith value in the input array. For example, this is our previous example, and prefix sum we calculated here is correspond to inclusive scan. Now I want you to pause the video and try to calculate the exclusive scan output for this input array. So pause the video now. Okay. Exclusive scan output would look like below. Notice we have not used ith element when we are calculating the ith element in the output array. For example, to calculate fourth element in the output, we have only used first three elements in the input, hence the value 6. So this is the difference between inclusive scan and exclusive scan. Now how about partial sum? Well, partial sum is also exactly similar to scan when we are using it with default add operator. Let me elaborate this. STL prefix sum implementation takes optional operator as an argument. In our implementation, we use addition operator to sum up the values, but you can use any operator with the prefix sum algorithm like multiplication, division, etc. So if you use default operator with partial sum, it will be identical to functionality of inclusive scan. But with inclusive scan and exclusive scan functions, we can provide the execution policy to notify the compiler that if possible, make it run in parallel. So let me now use STL version of prefix sum or inclusive scan and run it parallel using execution policy and measure the execution time for both sequential and parallel cases. So in our main function, let's call inclusive scan first without any execution policy and measure the execution time using high resolution clock as we did before. Then let's call it with par as execution policy to make it run in parallel. Now let's make the test element count to 1000 and measure the execution time. Okay, as you can see, when the element count is 1000, sequential implementation heavily outperforms the parallel version. This is usually due to added complexity of parallel version. Now let's increment the test size to 1 million element and see the outcome. Okay, now the results are different. Our parallel version outperformed the sequential version, but not in very large scale. So let's increment the test data size to 10 million elements. Okay, in that case, when we run this example, parallel version is outperformed the sequential version by substantial margin. In this case, it is 100 milliseconds faster than the sequential run. Okay, now we learn how to use prefix sum or scan algorithms with STL, and we have discovered what partial sum or prefix sum algorithm does. So in the next video, we will see how to implement our own version of parallel scan algorithm.